Our last lesson to the introduction of Euclidean geometry looks at the study of triangles or theorems that are related to triangles. Now, a good start would be to understand what a triangle is. Now, the word triangle consists of a part which has the prefix tri. Tri would mean 3, and this is attached to a part that says angle. And obviously, we already defined what an angle is in our very first lesson, where we said an angle is what is formed on the vertices of two lines, meaning when two lines intersect each other and make a vertex, the space in between there, we call it an angle. Now, at the end of the day, what we're saying here is that we have a word triangle, which basically says to us that we have 3 angles. Now, this as a geometric figure, it would look like this. So what we have here is that we have 3 vertices. We have 3 vertices. This vertex here and that and that. So that is 3 vertices. So that means I'll measure here 3 different angles that are different to each other. Sometimes they can be the same, but in general, let's say they are different. And not only that, with triangles, we also have 3 sides. So at the end of the day, a triangle would be a polygon that has 3 angles and 3 sides. Or one can say it is a shape that consists of 3 angles and 3 sides. Now, with that knowledge, we are going to then look at different theorems that pertain to triangles. The first theorem here would be Theorem 8, as we are continuing with our lessons. This theorem says that the sum of the interior angles of a triangle are supplementary. Now, as usual, we'll then have a short way of writing the theorem to say the sum of angles in a triangle. Because remember, our given information here is that we have a triangle. Obviously, these angles will be the interior angles. And this triangle that we are given, we then conclude to say the sum of its interior angles will then be supplementary. So this is to say this is our A part and this is our B part, our given part and the conclusion. Another way in which we can sometimes write this theorem in short is to say the interior angles of a triangle. So now what this means in terms of looking at it from a diagram perspective is that we have a triangle CAR, and obviously it will then have the interior angles. Hence we say the given part is that we have a triangle, right? We can say the sum of the angles in a triangle. Then we can conclude that if we have a triangle, we can then come to a conclusion that if we take these interior angles and we add them together, that is to say, if we take angle C, angle A, and angle R, that's what we're doing here. We must get 180 degrees. So that is our conclusion. Do you think that this theorem has a converse?